humanity has always looked to the stars. We have gazed into the velvet blackness of the night sky and wondered about our place in the grand cosmic ballet. For centuries, our vision was limited, our understanding filtered through the hazy atmosphere of our own world. But now, we have a new eye on the universe, an instrument of profound power and precision. The James Webb Space Telescope is more than just a machine. It is a time machine and a cosmic cartographer. It floats silently in the cold expanse of space, 1,000,000 miles from Earth. Its golden honeycomb mirror unfurled like a giant sun-facing flower. Its mission is one of the most profound we have ever undertaken, to look back to the dawn of time, to witness the birth of the first stars, and to peer into the atmospheres of worlds beyond our own solar system. This magnificent telescope is the culmination of decades of human ingenuity and an unyielding desire to know. It represents the collective dream of thousands of scientists, engineers, and thinkers who dared to ask the biggest questions. What is out there? How did it all begin? And the most tantalizing question of all, are we alone? The Webb telescope was designed to answer these questions by capturing light that has traveled for billions of years across the vastness of space. This ancient light carries secrets within its spectrum, tales of distant galaxies colliding, of stellar nurseries birthing new suns, and perhaps, just perhaps, the chemical fingerprints of life on a planet orbiting a star far, far away. The telescope itself is a marvel of engineering, a testament to what we can achieve when we work together towards a common goal. Its massive primary mirror, composed of 18 hexagonal segments of beryllium coated in a thin layer of gold, is optimized to see the universe in infrared light. This is crucial because the light from the most distant objects has been stretched by the expansion of the universe into the infrared part of the spectrum. In essence, Webb sees the unseen. It can penetrate clouds of cosmic dust that obscure the view of other telescopes, revealing the hidden processes of star and planet formation that have been shrouded in mystery until now. It is our sharpest, most sensitive eye on the cosmos. With this new power comes a new perspective. We are no longer just looking at the universe. We are actively exploring it in ways our ancestors could only have dreamed of. Every image Webb sends back to Earth is a postcard from another time and place, a piece of a cosmic puzzle we are just beginning to assemble. We are on the verge of a revolution in our understanding of the cosmos, a journey that will not only reshape our science books, but also our fundamental perception of ourselves and our place in the grand star-dusted tapestry of reality. The adventure has just begun, and the universe is waiting to be discovered. Just a stone's throw away in cosmic terms, a mere 4 light-years from Earth, orbits a small, dim star named Proxima Centauri. It's our closest stellar neighbor, a faint red dwarf invisible to the naked eye. Circling this star is a planet that has captured the imagination of astronomers and dreamers alike, Proxima B. This world is special. It orbits within its star's habitable zone, the Goldilocks region, where conditions might be just right for liquid water to exist on its surface. Not too hot, not too cold. And where there is liquid water, there is the potential for life as we know it. This makes Proxima B one of the most compelling targets in our search for extraterrestrial life. The James Webb Space Telescope has turned its powerful gaze towards this tantalizing neighbor, hoping to catch a whisper of its secrets. The challenge is immense. Proxima B does not pass directly in front of its star from our point of view, so we cannot easily study its atmosphere as it filters the starlight. Instead, scientists must use Webb's incredible sensitivity to detect the faint thermal glow emitted directly from the planet itself. It's like, well, trying to spot a firefly next to a searchlight from miles away. Yet, this is the frontier of exoplanet science, pushing our technology and our intellect to their absolute limits for a chance to answer a monumental question. What are we looking for? We are hunting for biosignatures, chemical clues in the planet's atmosphere that could indicate the presence of biological processes. Molecules like oxygen, methane, and carbon dioxide, when found in certain combinations, could be telltale signs of a living world. Imagine for a moment the telescope detecting a spike of dimethyl sulfide. On Earth, this compound is produced almost exclusively by marine phytoplankton. Finding it in the atmosphere of Proxima B would be a staggering discovery, a powerful though not definitive hint that something is alive over there. It's a detective story written on a planetary scale, but the environment around a red dwarf star is harsh. Proxima Centauri is known to unleash powerful stellar flares, bathing its planet in high-energy radiation that could strip away its atmosphere and make the surface inhospitable. So the search is twofold. First, does Proxima B even have an atmosphere? And second, if it does, what is it made of? The recent data from Webb, though preliminary, has sent ripples of excitement through the scientific community. The initial observations suggest the presence of a substantial atmosphere, a crucial first step. The next stage is to dissect its chemical makeup, a process that requires patience, precision, and a little bit of cosmic luck. To look through the eyes of the James Webb Space Telescope is to witness the universe as a celestial art gallery. The data it sends back is translated into images of breathtaking beauty and scientific importance, revealing a cosmos more vibrant and dynamic than we ever imagined. We see vast, colorful nebulae, the stellar nurseries where stars are born. These are not static clouds. They are turbulent, swirling cauldrons of gas and dust, sculpted by the radiation and stellar winds from newborn stars. Pillars of creation stand like cosmic sculptures, while the remnants of exploded stars expand outwards in intricate glowing filaments of superheated gas, enriching the galaxy with the heavy elements necessary for life. Beyond the nebulae, Webb's gaze extends to the galaxies, the great islands of stars that populate the universe. We see spiral galaxies like our own Milky Way, their elegant arms traced by the blue light of young, hot stars. We see massive elliptical galaxies, glowing with the golden light of ancient stars. And we see galaxies in the process of colliding, their structures distorted as they merge in a gravitational dance that will play out over millions of years. Most astonishingly, Webb allows us to peer back across 13 billion years of cosmic history to see the very first galaxies, faint red smudges of light that represent the dawn of cosmic structure, the seeds from which everything else grew. Closer to home, the telescope offers us stunning portraits of the planets in our own solar system, revealing them in a new light. We see the faint rings of Jupiter, the storms raging on Saturn, and the icy surfaces of moons in the outer solar system with unprecedented clarity. But perhaps the most profound sights are the exoplanets themselves. While we can't see them as detailed worlds, we can detect their presence and study their light. We see them as tiny, glowing dots of heat, their colors hinting at the temperatures and compositions of their atmospheres. Each dot is a world, a potential stage for its own unique story, a place with its own geology, its own weather, and maybe its own biology. Floating amidst this cosmic spectacle are our own emissaries of exploration. Sleek, futuristic spacecraft, designed for long-duration missions, glint in the starlight as they travel between observation points or service deep space instruments. Astronauts, clad in advanced suits that protect them from the harsh environment of space, perform delicate tasks on the exteriors of their vessels. They are tiny human figures set against the infinite backdrop of the cosmos, a powerful symbol of our species' relentless drive to explore and understand. Their presence transforms the cold, abstract beauty of space into a human endeavor, a shared adventure for all of us back on Earth. The exploration of deep space is no longer just a human endeavor or a robotic one. It is a symphony of collaboration between human ingenuity and artificial intelligence. Aboard futuristic spacecraft like the Stellaron 5, which serves as a mobile command center for Webb's deep space observations, scientists and astronauts work hand in hand with highly advanced technology. The bridge of the ship isn't filled with clunky buttons and switches, but with shimmering holographic displays that project three-dimensional star maps and real-time data streams from the telescope. An astronomer can literally walk through a model of a distant star system, manipulating planets with a wave of her hand to better understand their orbits. This advanced technology is crucial for making sense of the fire hose of data that Webb produces. Realistic robots with fluid movements and sophisticated AI assist the human crew with complex tasks. These are not the rigid, clanking machines of old science fiction. They are partners, capable of performing delicate repairs on the exterior of the ship, analyzing atmospheric data with incredible speed, and even offering strategic suggestions based on their analysis of probabilities. They free up the human crew to focus on what humans do best: creative problem solving, intuitive leaps of logic, and asking the big, what-if questions that drive discovery forward. The spacesuits worn by the astronauts are themselves marvels of engineering, and honestly, a far cry from the bulky suits of the Apollo era. These modern suits are lightweight, flexible, and equipped with augmented reality visors. As an astronaut works outside the ship, her visor can overlay technical schematics directly onto the equipment she is repairing, highlight potential hazards, and display vital life support information. This seamless integration of human perception and digital information allows for a level of precision and safety that was previously unimaginable. It turns every spacewalk into a highly efficient, data-rich operation, minimizing risk while maximizing scientific return. This synergy between human and machine extends all the way back to Earth. The scientists in mission control don't just look at screens, they enter immersive virtual reality environments that replicate the spacecraft's command center and the data it receives. They can collaborate with the astronauts in a shared digital space, troubleshooting problems and analyzing discoveries as if they were standing right next to each other, despite being millions of miles apart. This cosmic dance of humans, holograms, and robots represents the next great leap in our ability to explore the universe, combining the best of our creativity with the power of our technology. There is a profound human element at the heart of this technological symphony. For the astronauts aboard the Stellaron 5, the experience is, well, life-altering. To float in the silent vacuum of space, with the Earth a beautiful blue and white marble in the distance, is to gain a perspective that few will ever know. It's an experience that transcends science and touches the soul. One astronaut, looking out of the main viewport, might see the graceful arc of the Milky Way, not as a faint band in the night sky, but as a brilliant, sprawling river of stars, so close it feels like you could reach out and touch it. The sheer scale of it all is humbling. The daily life of an astronaut on a deep space mission is a mixture of rigorous scientific work and moments of quiet contemplation. They are the hands and eyes of humanity on the frontier, conducting experiments, maintaining the complex machinery of their ship, and communicating their findings back to a world that watches with bated breath. But in their downtime, they are simply human. They share meals, listen to music, and read messages from loved ones back home. These moments of connection are vital, grounding them in their humanity while they are adrift in an alien environment. They are explorers, but they are also sons, daughters, mothers, and fathers, carrying the hopes of their families and their species with them. The emotional weight of their mission is immense. When the first compelling data from Proxima B comes through, the atmosphere on the bridge is electric. The scientists and astronauts gather around the holographic display, their faces illuminated by the glowing graphs and chemical spectra. It's a moment of pure discovery, the culmination of years of work and a lifetime of dreams. There are no loud cheers, only a hushed awe as they collectively realize the significance of what they might be seeing. It's the feeling of standing on a shoreline and seeing a ship appear on the horizon for the first time. The dawning realization that your world is much, much bigger than you thought. This experience changes a person forever. Astronauts often speak of the overview effect, a cognitive shift in awareness reported by those who have seen Earth from space. But for these deep space explorers, there is an abyss effect. It is the feeling of looking out not at a single planet, but at an infinite sea of possibilities. It instills a deep sense of connection to the cosmos and a profound responsibility to continue the search. They are not just observing the universe, they are participating in it, becoming a part of its unfolding story. Their gaze into the abyss is humanity's gaze, filled with wonder, hope, and an unquenchable thirst for knowledge. We stand at a remarkable moment in human history. The data streaming back from the James Webb Space Telescope, particularly from our intriguing neighbor Proxima B, has brought us to the edge of a discovery that could change everything. The hints of an atmosphere, the faint chemical whispers carried across light years of empty space, have set the stage for an answer to the oldest question we have ever asked. It is a question that has been pondered by philosophers, poets, and scientists for millennia. Are we alone in the universe? For the first time, we have the tools to move this question from the realm of speculation into the realm of observational science. The search for life beyond Earth is more than just a scientific endeavor. It is a deeply human and emotional quest. It reflects our innate curiosity, our desire to find our place in the grand scheme of things, to find evidence of life, even simple microbial life, on another world would be a discovery of unparalleled significance. It would force us to reevaluate our place in the cosmos. We would no longer be the sole proprietors of life in the universe, but just one branch on a vast cosmic tree of life. It would be a humbling and profoundly unifying realization for all of humanity. Of course, the journey is far from over. Science is a slow, methodical process. The initial signs from Proxima B are tantalizing, but they are not yet proof. The next steps will require more observation, more analysis, and more debate. Every potential biosignature must be carefully scrutinized to rule out non-biological explanations. It is a scientific detective story of the highest order, with the highest possible stakes. But the possibility, however remote, that we are on the verge of confirming the existence of extraterrestrial life fills the air with an almost palpable sense of excitement and anticipation. So, as we look up at the night sky, we can do so with a new sense of wonder. The stars are not just distant points of light anymore, they are suns, many of which are likely orbited by planets. And on some of those planets, in the habitable zones around their parent stars, the same cosmic ingredients that led to life on Earth may have followed a similar path. Will we find definitive evidence of alien life soon? The honest answer is, we don't know. But for the first time, the answer feels within our reach. The universe is speaking to us, and thanks to the James Webb Space Telescope, we are finally beginning to listen.